The most damaging insect pest of apple and pear in North America, and indeed much of the world where those crops are grown, is the codling moth. The adult stage is a moth, as the name would indicate, but it is of course the larva that does the damage. The codling moth larva will enter through the fruit, tunnel to the center of the fruit where it does most of its feeding in the core on the developing seeds, and then exits, making another tunnel, destroying the fruit for commercial sale. The life history general aspects are indicated in this graph. Pupation will occur in some sort of protected site in a loose cocoon, such as bark flaps or other protected areas in the near vicinity of the tree. The adults emerge. After mating, they will lay eggs either on the leaves or the fruit. When the eggs hatch, they will then produce larvae that will enter the fruit, doing again most of the damage. All larval development is completed within the fruit, after which time they exit, crawl to find some sort of protected spot where they will spin a cocoon and ultimately pupate. During the winter time, the codling moth is present as a full-grown larva, so come winter, they find that location that's protected for them to get through the winter time, but do not pupate until the following spring. So again, under a bark flap or something similar, they'll pupate in spring, and the picture on the lower right indicates a larva that has undergone pupation, and later the adults will emerge. The adult of the codling moth is a small, brownish moth with a distinct coppery patch on the tip of the wings, fairly small, not likely to be observed under normal circumstances. If fruit is present, they will lay the eggs on the fruit. If fruit is not yet ready, then they will lay it on the leaves. And a pair of eggs laid on an apple fruit is indicated in the lower right. So eggs will be laid on leaves if fruit's not present, but fruit if it is. If you do observe the eggs, you can notice some indications of how far along it is in development. About halfway through egg development, you'll start to see what's called the red ring stage. And a couple of days before the caterpillars will emerge from the eggs, you'll see little dark heads. First egg hatch typically occurs shortly after petal fall, so the synchrony of the first generation is timed about the time that petals have dropped. The larvae will then bore into the fruit. In the entrance hole will be quite small, and there will be a little bit of frass of the excrement that they produce, indicating perhaps how they got in, and then they continue to bore through the center of the fruit, growing, getting larger, more extensively tunneling, and ultimately will bore their way out, and also you can see some sort of frass, some sort of excrement produced at the exit hole. Common points of entry of codling moth would be areas that are rough, so it could be the calyx end or the stem end, so that's often where they will enter the fruit, although not always. And if there's some sort of protection, such as where two fruit are touching, they will often enter in those sites too. So the larvae would do their development all within the fruit. There's very brief time spent after egg hatch on the exterior of the fruit, and then they tunnel right in and ultimately become full grown, after which time they'll exit. And again, you can see more extensive amount of frass being produced at the points where they have exited. They then seek that sheltered spot where they'll pupate, and during the growing season they will have a second generation and sometimes a third. So repeat a second and sometimes a third time each season. Usually it is the second generation that has the most damage potential because it is well synchronized with maturing fruit. And the first generation is time for just the beginning of when some fruit is available. The optimum timing for codling moth is a little difficult to do because this is an insect that very shortly after the eggs hatch will enter the fruit, at which time it's not possible to control it beyond that point. So there is a window, and that is whenever the eggs are hatching, but before they've gotten into the fruit. So this is the whole crux of the timing for optimally treating codling moth is when are the eggs hatching, when are the larvae still on the exterior of the fruit, and getting well-timed sprays for that window. So this has been worked out quite well, and there are ways that if you wish to optimally treat for codling moth, treat in a way that is going to have greatest likelihood of effectively catching this critical stage and would not be done before or after these critical period. You can use models that have been developed that combine use of pheromone traps, and I'll discuss that in a little bit to tell you when you start looking, and degree day models. So codling moth development is predictable, has been well worked out, and the models are based on the amount of accumulated heat, degree days, after a certain point, which we'll call the biofix. I'll talk about that in just a minute. But a degree day is a day when the average temperature exceeds by 1 degree the lowest threshold for development. So if the insect is not capable of developing, say, below 50 degrees, that's what we call the base temperature. If that day averages 55 degrees, there would be 5 degree days would accumulate in that day. If it was 70 degrees, average temperature, 20 degree days would accumulate. And again, the base temperature is the temperature you need to know, and that is with the codling moth, as it is with a fair number of insects, 50 degrees Fahrenheit. So below 50, if the average temperature is below 50, they will not be developing at all in that period of time. But above that, they will develop in relation to how much the temperature is above 50. There is an upper threshold. At 88 degrees, the codling moth will cease developing, so you don't accumulate any more degree days if it's above this upper threshold. So now the whole timing for these degree day models with codling moth is based on this biofix, which is determined by use of a pheromone trap. So in this case, we're using a pheromone trap baited with the lure of the female codling moth to get a fix on when the insects are emerging in spring, and then that is the beginning of when we start to take note of the degree days that have happened after that point. So the date when sustained captures of codling moths occur in pheromone traps, so if you catch one and then you don't get any more for 2 weeks, then that's not a sustained capture. So when you're starting to get them pretty much every night or every couple of nights, that's the beginning of the flight. That's when you start checking the temperature to get your timing right. So again, we use these pheromone traps that would have the lure of the female in it, and these would be only attracting males, so we cannot use these traps to control the insect since we're not catching females that are egg laying, but it is giving us the indication of the insect's activity. So the male codling moth will be captured, and again this shows some pictures of what you might see. The red and blue objects in the middle are rubber septa in which the pheromone is included. So if you were to buy this pheromone, it often comes out in a rubber septa, and then you drop that into the bottom of the pheromone trap that's sticky, and that will attract the males who will then get captured. So the predictions of codling moth activity are based on degree days that accumulate after biofix, and the beginning of the first generation egg hatch, the beginning of when you're first going to get eggs hatching, is about 250 growing degree days after the beginning of biofix. And in the graph on the lower right from Washington State, it indicates that usually takes up about 26 days after the first egg is after the biofix has been established, when you're going to start to get egg hatch. So it's not immediate. You don't get a moth and then they're going to be laying eggs then. Again, it might be 3 weeks. It might be a little shorter if it's very warm. It might be longer if it's cooler. The first generation activity will end at about 1,000 growing degree days, and the second generation activity you'll start seeing again at about 1200 to 1250 growing degree days after that initial biofix. So if you're tracking temperatures and just every day accumulating a little more, you can get an idea of when the first egg hatch is. 12% egg hatch is often considered an optimal time to make the first sprays. And then depending on how much longer the egg hatch is taking place because of the temperature, you may need to treat more than once during a single generation. But that's the timing. And most generation eggs, generation 1 eggs, are going to hatch between 360 and 660 degree days after that biofix. Now, there are also some cultural controls. If you can't spray the trees, and this would be difficult, or don't wish to, you can try some other things. The codling moth is quite an aggressive insect pest and is difficult to control very well with cultural methods alone, but there are some things that certainly can help reduce numbers and damage caused by this insect. So one thing is this fruit thinning issue that I discussed earlier, that where fruit that touches is often at a site where this insect is more likely to be successful in entering the fruit. So if you thin fruit so you don't have two fruit touching, you should have fewer numbers of larvae successfully entering a fruit. And fruit thinning obviously has some other advantages. It will result in larger fruit size, and if you have excessive amounts of fruit, then this will prevent a plant from going into biennial bearing, where they might yield heavily one year and then be very low the next year because of the stress of producing fruit the previous year. So thinning would be something to get out and do when the apples are small. Pick, of course, the bigger one if you've got a choice. And then cull fruit if you see larvae in them. If you see a fruit where the larva has gotten in, there's a little bit of that frass on the outside that indicates that it's entered, remove that fruit. And you'll have to destroy it because the insect can develop within that fruit and ultimately will emerge. But you cull it and you bury it or somehow dispose of it to prevent them from successfully leaving, pupating, and then producing an adult. High value fruit can be bagged, and it could be a fine mesh bag of some kind, and some of these are sold through garden catalogs that allow you to protect the fruit. This could also protect them from sun scald or other blemishes that might be caused by wind damage and the like. But obviously a lot of work, but it would work for protecting an individual fruit. You also may wish to try to trap out and destroy the population when they're at that point where they have spun a cocoon and under a bark flap or some other site, and they tend to be concentrated in a relatively small area at that point in time, and you can further concentrate them by giving them a good place to pupate, a good place to settle and spin the cocoon. So rough bark would be a kind of site that would be used on a normal tree, but you can provide them some other kind of suitable site, such as wrapping a tree with corrugated cardboard. A cardboard band would provide excellent pupation sites, and then the larvae would go in, they pupate in there, and then you could then destroy them. You would remove these burlap, or excuse me, these cardboard bands. Burlap you could use as well. If you had a burlap bag, you could tie it around the tree. They would also pupate in that kind of site too. But the point of this is to provide them a place where they'll pupate so that then you will destroy them. You're not just creating a housing project here for them. The point is for you to then collect it before they have transformed to the adult stage. Sometimes, frankly, these traps take care of themselves, because if you're in an area with earwigs, then the earwigs will go into these little corrugated cardboard protected sites for the codling moth, and they may well eat the codling moth larvae. Again, earwigs can be predators as well as plant feeders. So these would be bark flaps on the upper left with the larvae in their little cocoon, and then on the right would be some older but well-used corrugated cardboard bands. Again, burlap might be even easier to find and use for this purpose, but something to provide them cover that then you can use to concentrate them and remove them. And then, as I mentioned a little bit ago, this is an insect that mating disruption is working on. And in commercial orchards, mating disruption is not an uncommon practice for codling moth, particularly organic orchards, where it is the primary way to effectively manage this insect in the absence of some of the insecticides. It could be used in conventional agriculture. So again, to remind you, the mating disruption use of pheromones is in a way to directly control the insect, doing this by providing large amounts of pheromone over a wide area so that the whole environment is permeated with the sex pheromone of the female, preventing males from finding them. That's the mating disruption. They can't find the females to mate. And then the non-fertilized egg, females will then lay infertile eggs. So these would be some ways that ropes that are containing the pheromone that is used in mating disruption are being applied to trees. As I mentioned a couple weeks ago, the mating disruption is not appropriate for backyards, unfortunately. The way mating disruption works is it requires a large area to be permeated. And if you have a fairly small isolated area where you're using these high-release pheromone lures, then there is usually very nearby places where it is not permeating the atmosphere so much that it would prevent mating. So maybe 50 yards away, a female moth could fly, find a male who could successfully find her and mate with her. She returns then to the tree and lays fertile eggs, which defeats the purpose of mating disruption. So it has to be used in large blocks. Otherwise you'll get excessive mating in small blocks or where you have isolated plants. But again, this is a common practice in many of the commercial orchards and is allowed to be used in certified organic production. So that's the main points I wish to make for codling moth. Let's talk about some other fruit